Find me on Twitter at the Fagaholic. About a year ago, I got a bunch of cheap soldering stations from Amazon and AliExpress. One of them was this Prostormer station, which is no longer heating. This lasted for about a day before it broke. Pressing the up and down buttons adjusts your set temperature. Then after a while, it'll display the tip temperature. Oh, and by the way, about a year ago, these were going for $29.99 on Amazon. So again, I got this from Amazon roughly about a year ago. You can get them in different brands, but this brand is no longer available. So here's a Mypouos version and an Eastvolt version. This one is a Tekpower version. This one is from YCD. YCD, or Ningbo Yichenda, are actually the OEM manufacturer of this soldering station. Here are some of the notable specs for the station. You can see it accepts either a 110 or 220 volt input. It has a max power consumption of 75 watts. The temperature range is between 200 and 480 degrees Celsius. It takes an A1321 pluggable heater, which we'll get into later. Tip to ground resistance is below 2 ohms, and the tip to ground voltage is below 2 millivolts. But the best features to me are the auto sleep and auto power off features. Here's the box that was shipped in. You can see it comes nicely packed. This comes with 5 tips, a coil of solder, a sponge, a soldering iron handpiece, which uses standard T18 or 900M tips, and a soldering iron handpiece holder with the cleaning stuff. This one is much higher quality than the ones that you may have seen with the sharp edges. The thing I don't like most about the station is the display. It should have been tinted so you don't see the segments underneath and make it easier to read. Otherwise, pretty standard stuff here. Power switch on the side, GX12 6-pin socket in the front. Oh, another thing I don't like is a non-detachable power cord. First thing I'm going to do is check to see if the heater or heating element is okay. This is what they mean by pluggable heater. The A1321 heater that was mentioned earlier is also referred to as a 936C trapezoidal type heater. Apparently the middle 2 pins are the temperature sensor and the outer 2 pins is the heating element. Resistance for the sensor is about 48.7 ohms and resistance for the element is around 3.5 ohms. The sensor measures at 50.5 ohms, which is in the neighborhood of 48.7 ohms, which looks good. The element measures 3.2 ohms, which is close to 3.5 ohms, which looks good. So with the element okay, there's gotta be some sort of continuity problem within the handle itself. Pins 4 and 5 connect to the sensor and is reading 51.2 ohms and looks okay. Pin 3 connects to the handle spring, which in turn connects to the tip and looks okay. Pins 1 and 2 connect to the element and is reading infinite or open and is not okay. So the issue's been narrowed down to the heater circuit within the handle, which makes sense because there's a temperature display on the soldering station. Now I'm going to test continuity between the heater plug and the aviation plug. Again, the middle 2 pins on the heater plug is for the sensor, so this should test okay. This one connects to pin 5 on the aviation plug. This pin on the heater plug should connect to pin 4 on the aviation plug. What? Damn, the right sensor socket was pushed in and was probably barely touching. And the right element socket was pushed more in, so it wasn't touching. Most of the times you can access the internals of the handle just by pushing up on the cord. But in this case it's stuck, so you're going to need something to push it out. And in this case I'm using a barbecue stick. You can see here the yellow and gray socket pins are recessed. So simply just pushing them back in will do the trick. Easy fix, but check out SW-200D. That's the shake sensor. Its purpose is to wake up the soldering station when it's sleeping. Movement while picking up the handle will wake it up. It's wired in series with pin 6 on the aviation plug to the left side sensor pin on the heater plug. Let's see how the shake sensor works. The shake switch is connected from pin 6 of the aviation plug to the right side sensor pin on the actual heater. Pin 4 on the aviation plug also connects to that pin, as indicated by the multimeter. You can also read the sensor's resistance through pins 5 and 6 on the aviation plug. Check this out. Anytime the shake sensor is pointed upward past 90 degrees or horizontal, it goes open. Pointed downwards past horizontal, it closes. Shake a little bit and resistance on the shake sensor goes up. Shake it hard enough and it actually goes open. Even the slightest shake is sensed. Here's some schematics of the aviation plug going to the heater plug and to the heater itself. Okay, testing time. Let's see how quick the soldering station comes up to temperature. Pretty dang quick for a 936 station. 6337 solder melts at 183 degrees Celsius. I want to see how quickly the solder melts when set to that temperature. It'll give me a ballpark idea of how accurate the temperature readings are. The lowest set temperature for this station is 200 degrees, but let's try it anyway. Here's the unit going to sleep after a specified time. Minimum wait time for the unit to go to sleep is 1 minute after the handle is at rest. The shake sensor is pretty sensitive, so any movement of the handle will wake up the unit. After the unit has gone to sleep, it'll do a full shutdown after a specified time. The minimum time the unit shuts down after it has gone to sleep is 1 minute. The only way to turn it back on is the power switch. To adjust the amount of time for the unit takes to go to sleep after the handle has rested, press and hold on the front two buttons until you see an L in the first digit. Adjustable range is between 1 and 99 minutes. With the unit showing an L, press and hold on the front two buttons until you see a P on that first digit. This adjusts shutdown time and is adjustable between 0 and 99 minutes, 0 being disabled. Holding down the front two buttons in P mode until you see a C will let you adjust between Celsius and Fahrenheit. Letting the unit sit for about 5 seconds after the last button has been pressed will return to normal mode. By the way, that flickering on the display really only shows up during well-lit video. The display is stable when looking in person. Now let's check to see if the unit is really ESD safe. To do this, let's check to see if the tip is tied to earth ground. This is important because any type of voltage leak at the tip will be synced directly to earth ground. This is important for components like, say, a laser pickup, which has ESD warnings all over the place before you take off that solder blob. Looking back at the specs, tip to ground resistance was supposed to be less than 2 ohms. There's the variable resistor that you can use to calibrate your temperature. Damn, both the shake sensor and the tip pins are not even soldered in. The shake sensor pin is barely making contact. Here's mains ground coming directly from the power cord. It connects directly to the top of this AC step-down transformer, which in turn connects to this yellow wire that leads to the board. Typically, these 936 stations step down power to 24 volts. Just gonna confirm continuity is good through the ground wires. This confirms ground to that point on the board, which is supposed to connect to that tip pin. Look what I got from TME. This got here to Hawaii from Poland in 4 days. Damn! These authentic JBC T245 tips cost more than a Prostormer station. This hook tip will make it easier to solder with the board in the case. This is my first time trying out the Ikesun T3A and a JBC tip. So let's see how this goes. Heat up is really quick. Use the lowest possible temperature as it'll save your tip and sometimes save what you're working on too. The best thing about this station is the auto sleep when the iron is put back into the holder. It's really going to prolong the life of the tip. I really do need to get some better flux. Let me know what flux you use and would recommend me to get in the comments below. Did I say I need better flux? In case you were wondering, the unit is fused at the switch. And I found out later that the front panel can't separate from the upper case. It'll make soldering with a standard straight tip much easier. Also, the unit displays an SE code when it doesn't detect the thermocouple or temperature sensor. Okay, now that we got ground properly soldered to the station, let's measure tip to ground resistance. It's supposed to be equal to or less than 2 ohms. Here, I got leads connected to mains ground through this power strip that's connected directly to alligator clips to the multimeter. I'm going to change out the red leads to alligator clips. You can see the readings for tip to ground resistance is pretty unstable, even with a good connection provided by the alligator clips. Obviously, the tip is not making good contact with the ground line. There are two places of contact for this. One is the inner sleeve. HAKKO's genuine T18 tips are shorter than the generic 900M tips. So like in this case, the tip is barely making contact with the inner sleeve. I'm simply raising the sleeve a bit. The other point of contact for the tip to the ground line is through the outer sleeve. Make sure both the tip and the sleeve are clean at this point of contact. Here's a comparison of a genuine HAKKO T18 tip and a 900M tip. Notice the 900M tip is longer. Much better. Now the tip to ground resistance is less than 2 ohms. With that sorted out, we can now measure tip to ground voltage or tip voltage leakage. Wow, rock solid nothing on AC measurement. And 1 millivolt on DC measurement. I'm upping the temp to see if there's any movement. Up to 2 millivolts on DC and nothing on AC. Yup, this soldering station has earned that ESD safe badge. Now let's try to measure tip to ground voltage with the station floating. To do that, I'm removing the spring that connects the tip section to the ground line. The other lead is still connected to mains ground. Even with the system off, I'm getting over 100 millivolts. With the system on, it jumps to nearly 300 millivolts. And climbs over 500 millivolts at the higher temperatures. I don't expect to find much DC voltage as the station uses an AC transformer. But yeah, I guess I'll have to test the soldering station for voltage leakage each time I solder or mess with a delicate part. So I just got this ray gun handle that I'm going to hack to use with the HAKKO T3A station. I think the HAKKO 936 handle feels cheap, and I really like the form factor of this ray gun handle. Here's a comparison with the Prostormer handle. The ray gun is about 1/2 to 3/4 inch shorter. The handle uses a standard A1321 heater. This heater has the same characteristics as the pluggable heater in the Prostormer handle. Here we see 52 ohms for the sensor and 3.8 ohms for the heating element. Plugs for both the Prostormer and the ray gun handles uses a GX12 6-pin plug. Both aviation plugs are similar in form. You'll need to add a shake sensor to the ray gun handle if you want to use the sleep and auto shut-off functions of the Prostormer station. Otherwise, it's fully compatible.